Okay, that was quick. So what we're going to do, this is the problem that we had left off with in our last video. So I want to pick up with this problem, and you might have already tried to work through it. And so let's pick up with this next video, or in this next video, with this problem. And we've got to multiply with what's left. So here we go. 4 times 2 is 8, minus 12 times x is 12x, minus 6 times 1 is 6, equals 3 times 3x is 9x, 12 times 2 is 24, and then plus x times 4 is 4x. Okay, now I've got a little bit something extra to do here in this problem, because if you'll remember, in the last, in section 2.1 video part, I believe it was part 2, I told you this. I said, whenever you're solving an equation, always do everything you can on each side to simplify both sides first. Then get your x's on one side and get your numbers on the other. So if you'll notice on this left side, this is a variable term, but this is a number term, this is a number term. So I can combine these two terms. On the right side, I can combine the two x terms together. So let me do that. So on the left side, I'm going to bring down the negative 12x, but I'm going to combine the 8 minus 6. 8 minus 6 would just simply be plus 2, equals. Now the right side, 9x plus 4x is 13x, and then just bring down the minus 24. Okay, now we're back to that two-step problem again. So I'm going to subtract 2 from both sides, so it'll be a minus 2 over here, and I'm going to minus 13x from both sides. So that minus 13x will show up over here. And then the minus, now remember that 24 is still negative. The 24 shows up, the 2 over there, subtract 2 from both sides. All right, if you lose 12 and then you lose 13 more, you have lost 25. And then if you lose 24 and you lose 2 more, you've lost 26. Divide both sides. By negative 25, the coefficient, it cancels. A negative over a negative is a positive, and no 26 over 25 does not reduce. All right, I want to do 2 more examples with you on fractions. So let's do this example right here. Let's do 2 plus x plus 3 over 5 equals x minus 1 over 3 minus x. Okay, so if you'll notice in this problem, you have 1, 2, 3, 4 terms. So there's 4 terms in this problem. All right, I've got a dividing, and let me say this. This fraction bar, I know there's a plus sign here, but because that fraction bar is under all of that, this is considered one term. This is considered one term. All right, so let's say we've got a dividing 5 and a dividing 3. So to get rid of a dividing 5 and a dividing 3, multiplying by 15 will do. But remember, you got to do all 4 of these terms by 15. We'll put a 15 here, 15 here, 15 here, and a 15 here. Now the famous 3 words, what are they? Cross, cancel, first. All right, there's no canceling here. This 5 into 15 leaves 3. This 3 into 15 leaves 5. And then there's no canceling here. So here's what we've got left. 15 times 2, which is 30, plus. Now this is where you have to be careful. When you cancel this 5 into this 15 and it leaves 3, this 3 has to multiply everything else that you see there. So when you do this, this is not going to be 3x plus 3. This 3 has to multiply both of these terms in that numerator. So it's going to be 3x plus 9. Same way on the right side. When you say 3 cancels with 15 and leaves 5, this 5 has to multiply everything that's left in this term. So it's distributive property. So it's not going to be 5x minus 1. It is going to be 5x minus 5. And then, of course, x times 15 is 15x. Now I'm going to clean up both sides. If you'll notice on this left side, you got a 3x, but you can add the 30 plus 9. When I add the 30 plus 9, of course, that's 39. Equals. Now, on the right side, bring the 5x down. I can combine the two numbers there, or constants. If you lose 5 and then you lose 15 more, you have lost 20. Now we're back to the two-step problem again. Subtract the 39 across, because it's positive. Subtract the 5x from both sides. When I do, if you do it in one step, this is what it will look like. Now don't lose that negative in front of that 20. So I would have negative 2x equals negative 59. And then to get rid of the coefficient of x, divide by negative 2. Get x equals 2. And once again, that's been happening a lot lately, a negative over a negative is a positive, and 59 over 2 does not reduce. Okay? Let's do another example. Doing more with fractions because these are the ones that's usually a little harder for us. So let's look at this example. X over 2 plus 2x minus 1 over 3 equals 2 minus 3x minus 2 over 4. Okay, let me say once again, notice this is one term, 2, 3, 4. First thing I see with this equation is the fractions. I don't like the fractions. So what I want to do is I want to get rid of the fractions. I can do that with an equation. How do I do that? By multiplying through by a big enough number. So I have a dividing 2, a dividing 3, a dividing 1, and a dividing 4. So what I'm going to do is multiply through 2, 3, 4. So I'm going to multiply through by 12. When I multiply by 12, I'm going to have to do all 4 of these terms. So I will put 12 here, 12 times that term, 12 times that term, and 12 times that term. What's our 3 famous words? Cross, cancel first. So 2 goes into 12, 6. 3 goes into 12, 4. If you're not careful, you'll say 2 goes into 12, 6. That 2 is not in the denominator. It's in the numerator. This is 2 over 1, so there's no canceling here. But then 4 goes into 12, 3. Now multiply what's left. Well, 6 times x is 6x. Plus, now be careful right here. This 4 has to multiply everything that's left. So it's 4 times 2x, which is 8x. But then don't forget to say 4 times 1, which is 4. Now the right side. 12 times 2, 24. Minus. Now, be careful right here for 2 reasons. One thing is this. When I cancel the 4 into the 12, it leaves 3. Make sure you multiply the 3 by both of these. And you say, okay, Mr. Reiner, I've got that. But here's the next thing you have to be careful about. don't forget that this 3 has a negative with it. So it's negative 3 times 3, but then it's negative 3 times negative 2. So be real careful. It's easy to make a sign mistake there. So negative 3 times 3 is negative 9x. And then negative 3 times negative 2 is plus 6. Now, let's clean up both sides. So we've got 6x plus 8x, which is 14x minus 4, equals, on the right side, I only have one x term. I'll bring it down. And then 24 plus 6 is plus 30. Well, here we are again. Two-step problem. If I do it in one step, adding 4 to both sides, so the right side would become 30 plus 4, and then adding 9x to both sides, the left side would be 14 plus 9x. And remember, when you add the 9x over here, it adds out. That's why we don't show that. So this is 23x equals 34. Then divide both sides by 23. So x equals to 34 over 23. All right, I'm going to do one more example here to close out the section with fractions. Okay, so let's look at this problem right here. Okay, let me, of course, this is one term. Talked about that. This is one term. Yes, you could go ahead and reduce this if you want to, but I'm going to go ahead and just leave it as that. This is one term. This is where you have to be careful right here. What mathematical operation is right here? It's multiplication. So, remember, multiplication is like glue. It holds a term together. So this is considered to be one term, not two. This is not two terms. If there was a plus here or a minus here, it would be. But it's not. So this is 1/3 times this. And you say, well, could we distribute this first and then it would be two terms? Yes, you could. But holding to what I told you I like to do, if an equation has fractions, I get rid of the fractions first. So remember, there's multiple ways to work this, but I'm just doing it the same way every single time. So let's see, dividing 6, dividing 6, dividing 3, dividing 2. So 6, 2, and 3 all divides evenly into 6. Now you say, Mr. Matter, what if I'd multiplied 3 by 12 and not 6? That will still work. It's just your numbers are going to be bigger, so you have to reduce your answer. But as long as you use any number that all of your denominators divide into, it's just best to use the smallest one that they all divide into, which is called the least common denominator. So I'm going to multiply all 4 terms by 6. 6, 6, 6. 6. Famous 3 words. Cross cancel first. 2 into 6 is 3. 3 into 6 is 2. 6 into 6 leaves 1. 6 into 6 leaves 1. Now multiply what's left. So 3 times 1, of course, is 3. Minus. Now, when you multiply this out, go straight across from left to right. All right, here we go. 2 times 1 is what? 2. Now you got to take that 2 and distribute it to both of these terms. But don't forget that this 2 is negative. So it's negative 2 times 2, which is negative 4x, and it's negative 2 times negative 3, which goes to plus 6. That's where we usually make our mistake right there. Equals 1 times 2x is 2x minus, now, you say, well, we're distributing by 1, so that doesn't change anything. That is true. But don't forget that this 1 is also negative. So it's negative 1 times x, which is negative 1x, but then it's negative 1 times negative 3, which makes that now go to a plus 3. All right, now all of the fractions are gone. Now clean up both sides as much as possible. So the left side would be, I'm going to bring down the negative 4x, and then 3 plus 6 is plus 9, equals, the right side, 2x minus 1x is just x plus 3. Now we want to get the x's on one side, we want to get the numbers on the other. So if I do that in one step, get this, and this would be negative 5x. Now notice I'm not talking as much about that now. At this point, you should be very comfortable with adding, subtracting, multiplying, and dividing positive and negative numbers. And a negative divided by negative is a positive. So the answer to that is 6/5. Okay, the last thing I want to do in this section is I want to talk to you about, so we've talked about equations with fractions in it. The last thing I want to talk about is, and you will rarely run into this, but we'll use this a little bit later on in the course, so that's why we introduce it now. And you only have maybe 3 or 4 homework problems dealing with this. But I want to show you one of the ways, because there's multiple ways. I want to show you one of the ways on how to deal with equations that contain decimals in them. And that will take us to our next video, which I believe is part 6. But anyway, so I'm right at the 20-minute mark, so I will stop here and we will finish up with that. This next video probably will not be 20 minutes long because it will completely close out all of the stuff in section 2.1.